ఇప్పుడు అటువైపు నెలలో కూడా కనపడుతుందిగా నేను మామూలుగా ఇటు నుంచి ఇటు వచ్చిన. ఓకే. Good morning, students. So in previous class we are starting a chapter environmental chemistry. In that we are discussing about atmospheric pollution. That atmospheric pollution will be of different types. One is due to air pollution. In that air pollution we are discussing some points about gaseous pollutants and particulate pollutants, and one more small topic will be left in that content, that is depletion of ozone layer. Depletion of ozone layer. Actually ozone layer is formed in troposphere. O3 is present in a troposphere. So we know the advantage of ozone layer in a troposphere, that prevents the fall of UV radiations which came from the sun radiations. Let us discuss how ozone is produced in a troposphere. In this troposphere, first of all, that oxygen gas will absorb ultraviolet radiations and produce atomic oxygen. So oxygen is present in atmospheric air, especially in a troposphere. By the use of UV radiations, that oxygen molecule dissociate to give oxygen atoms, that is atomic oxygen. Now that atomic oxygen will combine with another oxygen molecule in presence of UV radiations and a mixture of N2 and O2. It produces O3 gas. Here there exists equilibrium between the oxygen and ozone, because ozone is highly unstable, that will be dissociated to produce oxygen molecule and atomic oxygen. So in this way ozone is present in troposphere. Mainly this ozone is depleted by two factors. One is NO, which is released from supersonic jet planes. Supersonic jet planes. And another one is CFCs, or we commonly called as freon. So these two will damage or decreases the concentration of ozone layer in troposphere. That decrease in concentration of ozone layer in troposphere is nothing but ozone holes. So here the decrease in concentration of ozone in troposphere indicates formation of ozone holes. Actually these CFCs are boon to industry. Boon to industry and curse to environment. Curse to environment. So industrially it has more important, because it is less weight, easily transportable. So industrially more useful, they are boon to industry. But at the same time they curse, because they will damage the environment. They are curse to environment. Let us consider an example of freon, CF2Cl2. So here that CF2Cl2 reaches to the troposphere. So actually CFCs or freons are used in air conditioners and refrigerators. So which produce cooling effect, air conditioners and refrigerators. So whenever they are released in the stratosphere, due to the less weight, they reaches to upward and reaches to troposphere. After reaching that troposphere, that chlorofluorocarbons will be split into chlorine radical acid of CF2Cl radical. Actually, one CFC molecule will deplete lack of ozone molecule through chain reactions. Through chain reactions. So that initially formed chlorine will combine with the ozone molecule to produce ClO radical along that oxygen. Now that chlorine monoxide radical again combined with atomic oxygen to produce chlorine radical along that oxygen. So initially that related chlorine radical, initially the released chlorine radical will be produced so many number of chlorine radicals. That's why one CFC molecule will deplete almost 1 lakh ozone molecule. So in this way, huge amount of ozone molecules will be depleted. That's why ozone holes will be formed. So what are the drawbacks due to the formation of ozone layer? The main thing is when they reaches to earth, they falls on the skin, that aging of skin will be takes place. Aging of skin takes place. Second thing is skin cancer will be produced. Skin cancer will be produced. And also causes cataract problems. Cataract problems. So these three effects will be directly influenced on human beings. One thing is aging of skin. Second thing is skin cancer. Third thing is cataract. At the same time, that aquatic life will be also suffer because of the fall of these UV radiations. That fish productivity will be decreases. That phytoplanktons growth will be increases. And at the same time, that inanimate objects like paints. So actually for buildings we can protect, paints will be done. Those paints will be also will be delayed due to the fall of UV radiations. So these are the drawbacks which are identified whenever that ozone holes are produced. So it is also one of the important factor which destroy the environment. Okay. Now we move to water pollution. So after the completion of atmospheric air pollution, the second thing is water pollution. So generally water bodies are mainly polluted due to several factors. Among them, the first thing is from industrial waste. Along that, domestic waste also. So the first thing is industrial and domestic waste. Second one, spillage of oil during transportation through ships. These two are the main things which causes the water pollution. Along that, one more thing, that use of pests and fertilizers, they also cause the water pollution. Let us discuss one by one. Industrial and domestic waste. Actually, industries are developed day by day due to the increase in population. So, whatever may be the things that are required for humans will be developed or produced by improving the industries. So, various waste will be released in the industries. Those chemicals will be directly released into the water bodies, will cause the water pollution. Actually, that pure water has no smell, no color, no bad odor. Due to the release of these waste in water, that water will be polluted. That polluted water sample will be analyzed by using different methods. Already we are discussed in the previous class. By calculating the COD or BOD values, we can identify that water is polluted or how much level it is polluted. Okay. So here, due to the release of direct waste into the direct water bodies, the water bodies will be polluted. For this, an example we are discussed, that is Minamata disease. Minamata disease. Actually, that Minamata disease is observed in Japan. Minamata is the one of the Bay of Japan. So we know that Japan is the various island combinations. In that, Minamata is the one of the bay. Behind that bay, there is an industry which produces mercury as pollutant. So mercury is released from industries, is directly released into the seawater. That's why the mercury will be entered into the food system. What is a food system? Actually, that transport of various levels of pollutants through food chain. For example, that liberated mercury, released mercury will enter into the water body. That will be the taken by the small fishes. So mercury will enter into the small fishes. From that small fishes to that will mercury enter into the larger fishes. After that, by the entering into the food chain, either small or large, by birds. From that birds to living system. So in that food chain, that fish is also taken human beings. So in this way, that mercury will be enter into the food chain. So actually this defect will be identified at the Bay of Minamata. That's why the disease obtained in this way is nothing but Minamata disease. So actually that is mainly due to industrial waste. Coming to the domestic waste. So domestically we can use soaps and detergents. Soaps and detergents. For bathing purpose, we can use soaps. For cleaning purpose, either clothes. Along that, kitchen, dishwash bars. Are commonly regularly used in domestic purpose. Okay. So, whenever we can use these soaps or detergents, they enter into the water body, because whatever may be the waste released during the use of these detergents or soaps will enter into the water bodies. Okay. So, if you can use the soaps or detergents or dishwash bars, directly they are entering into the water body. Actually, these soaps or detergents will contain that nitrates and phosphates. Nitrates and phosphates. So, these nitrates and phosphates will act as micronutrients, for the growth of algae or seaweed. Actually, that water bodies contains algae or seaweeds. Due to the direct entry of these nitrates and phosphates, they can act as a micronutrients. So, as a result, there is a abnormal growth of seaweeds and algae. That's why that lake will be occupied by the seaweeds and algae entire space, so that fall of sun rays into the water body will be decreases due to the occupation of these green algae. That's why gradually oxygen levels decreases. As a result, oxygen levels in water body decreases. Water body decreases. So, the fishes and other aquatic life, mainly fishes, are present in the water body. So, due to the lack of oxygen, because of the abnormal growth of these seaweeds and algae, that oxygen levels in the water body decreases. Due to this, the aquatic life will be suffered. Aquatic life is dead. And gradually the water will be evaporated. As a result, sedimentation takes place. So, this sedimentation is nothing but drying of water. Due to the drying of water, that mud will be placed at the bottom of the lake, and this is sedimentation. This entire phenomena is known as eutrophication. So, one of the important question about eutrophication. So, for that eutrophication, which is the major reason? Domestically released nitrates and phosphates, which are present in the soaps, detergents or dishwash bars, will enter into the water body. That gradual drying up of lake and sedimentation takes place. This will affect the aquatic life, and that gradual drying up of lake is known as eutrophication. So, one more important point, definitely you must note that point, eutrophication. So this is the mainly adverse effects which are taking place due to industrial and domestic waste. Coming to the second point, that spillage of oils during the transportation through ships. So actually that crude oil will be transported mainly various regions through ships, because less expenditure and more easy transportation will be through ships. During the transportation, in some cases, if there is any accidental case, that spilling of oil will be takes place on the water body. That huge levels, almost kilometers of levels will be spreaded by the that crude oil in case of any accident. Then ultimately, that thick layer will be obtained on the surface of the water. As a result, that oxygen levels in the water decreases, that aquatic life will be dead in that huge area. So care must be taken in order to transportation, mostly without leakage of the tanks. That is more important. Coming to the third one, that use of pests and fertilizers. Actually, for a good growth and killing of insects, we can use pests and fertilizers. So in agriculture sector, mostly in agriculture sector, we can use pest and fertilizers. By the use of pest, we can control the insects. By the use of fertilizers, we increase the growth of product. They can also cause the water pollution, because by spraying of these chemicals on the plant, the plants cannot absorb complete things. Some more fertilizers or pests will be placed on the leaf surface or on the behind the stems. During the fall of rain, what happens? That whatever the pest and fertilizers will be left on the leaves of the plant or the stems of the plants will move along with water. When these water will pass through the fields, these pests or fertilizers will be dissolved in it and they can directly enter into the water bodies. So in that way, water will be also polluted. So actually that polluted water will cause so many drastic conditions to human beings or animals, whatever it may be. Because by the use of such kind of water will causes certain disorders in the human beings. For example, generally for the transportation of water in olden days, lead pipes are used. Actually, that permissible level of lead in water is only 50 ppb, parts per billion. Whenever this concentration greater than 50 ppb, parts per billion, it causes harmful effect. So whenever that lead level is greater than 50 ppb, it causes liver damage, kidney damage. Liver, that damages liver, kidney, and also affect the reproductive system, and also affects the reproductive system. Okay. So what about the permissible level of lead in water? Only just 50 ppb, up to 50 ppb, there is no effect. But whenever its concentration greater than 50 ppb, it causes liver damage, kidney damage, and affects the reproductive system. Coming to the sulfates, here that sulfates level, permissible level is only up to 500 ppm, up to 500 ppm, parts per million, 500. If its concentration greater than 500 ppm, if its concentration greater than 500 ppm, it causes laxative effect, laxative effect means motions will be takes place. So by taking of water, having more level of sulfates in water, they cause laxative effect, they will create motions. And one more important thing, that is nitrate ions. So here that permissible level of nitrate ions in water is only up to 50 ppm. If its level crosses to more than 50 ppm, it causes blue baby syndrome. It is also called as methaglobamine, blue baby syndrome. So in this lane, different ions level will be limited in water. If we cross that limit, ultimately it affects the adverse effect on human being or animals. That's why we must restrict that level of the pollution in water. So one more important thing is fluoride ion. So fluoride ion's level with a certain minimum level is definitely required for our health, and heavy doses of fluoride ions in water will cause the harmful effect to the human being. Let us discuss about that fluoride ions. So the permissible level of fluoride ions in water is permissible level up to 1 ppm. It is necessary for human beings because our tooth will be protected by enamel, which is nothing but fluorapatite. That fluorapatite is formed from hydroxyapatite. We know the formula of hydroxyapatite: Ca3PO4 taken twice, CaOH twice. It is the formula of hydroxyapatite. So this hydroxyapatite is converted into fluorapatite by the use of fluoride ions present in the water. So what is the permissible level of fluoride levels in water? So up to 1 ppm of F minus, they convert that hydroxyapatite into fluorapatite. That formula of fluorapatite is Ca3PO4 taken twice, CaF2. This is fluorapatite. This fluorapatite is useful to protect the teeth. So that enamel of teeth will contain fluorapatite. So the minimum permissible level of fluoride ions in water is 1 ppm. More than 1 ppm, it causes adverse effect. If fluoride's level is up to 2 ppm, so if the fluoride's level in water is more than 1 ppm, that is nothing but when it reaches to 2 ppm, what happens? It forms a brown color mantle on teeth. So when fluoride levels is more than 1 ppm, that is up to 2 ppm, brown color mantle will be observed. Brown color mantle on teeth is observed. If its level is very high, that means if fluoride's level is up to 10 ppm, it causes severe damage to the body, and that disease is nothing but fluorosis. Fluorosis, very, very dangerous. So whenever that level of fluoride ions reaches to 10 ppm or more than 10 ppm, that will be adversely affect on the human beings and causes that disease fluorosis. So what happens here? Here, that excess level of fluorine will combined with calcium. Actually, that human body contains calcium in the form of bones and teeth. So due to the excess level of fluorine, whenever its concentration reaches to 10 ppm or more than 10 ppm, that body bones directly reacts with fluorine and forms calcium fluoride. That's why the strength of calcium on the bones decreases. So the bones will become so bent and causes severe pain. So when a person is attacked by the fluorosis, just like a 16 years person will appear as a 60 years old man. So we know the difference between a 16 years person and a 60 years old person. So at the age of 16, the person will be very stiff and abnormal growth is identified. Whereas in case of 60 years, that body becomes to bend. So such kind of things will be identified whenever that fluoride levels in water will be more than or equal to 10 ppm. So in this way, we must restrict that fluoride levels in water. In case of up to 1 ppm, there is definitely need of fluoride levels in water. If more than that level will adverse effect to the human beings, especially in some areas, Prakasham, Nalgonda district, mostly these fluoride levels of water, fluoride levels in water will be high. So in cases, various techniques are used to reduce the fluoride levels. That is not present in our syllabus, that is the beyond that limit. Okay, these things must be rememberable. If water has no fluoride ions, then what happens? Up to 1 ppm, there is definitely helpful. If that water does not contain any fluoride ions, then what happens? At that stage, that fluoropatite formation is not possible. In such cases, we can use fluorinated paste that will be prescribed by the dental doctor. Okay, so this is all about fluoride levels. So after this, we enter into that last one, that is soil pollution. So here, soil pollution is also major disorder to human being. The soil pollution will be takes place in different ways, by the use of chemicals mostly. So already we have some idea about the use of pesticides and fertilizers. If these pesticides and fertilizers will be stay on the soil surface, abnormally the soil will be affected. Especially in World War II, in that World War II, DDT is very much used. DDT, dichlorodiphenyl trichloroethane. What is the purpose of this DDT in case of Second World War? To prevent malaria. to prevent malaria. That means malaria is identified due to the mosquitoes. So to kill the mosquitoes, that DDT is used at the time of Second World War. After that Second World War, that malaria can be used after it can be used as insecticide on plants. But so many countries will be banned DDT as used as an insecticide because this causes more harmful effect on further on human beings. That's why most of the countries will be banned DDT. And various chemicals are prescribed to kill the microbes or insecticides, because by the use of a chemical continuously on an insect, gradually resistance will be developed in that insect and that chemical cannot work on it. So that DDT can be replaced by aldrin and deldrin. That second step, aldrin or deldrin, they can be used as insecticide. Later on, some herbicides also used. Further step, herbicides. Those herbicides, for example, sodium chlorate. We know the formula of sodium chlorate. That herbicides, NaClO3, sodium chlorate. Along that, sodium arsenite, Na3ASO3, sodium arsenite. So these can be used as herbicides. So all these will functions as insecticides to kill the insects on the plants. So if you can use these insecticides, gradually they will be stored in the surface of the soil. So in that way, that soil will be polluted. And that direct release of waste, industrial waste, that direct release of industrial waste can also cause soil pollution. So whatever may be the various chemicals that are released industries are directly stored on the certain area. So that chemicals flowing area will be destroy the fertility of the soil. So that's why soil will be more polluted by the use of industrial waste, by the release of industrial waste. So in this way, that soil pollution will be majorly occur. Now, how can you reduce these kind of pollutants in environment? That is the major thing. That's why we can select some precautions. For example, we can limitize the flow of chemicals which are released from the industrial area is only limited to certain boundary, will reduce the soil pollution. So that only industrial zone will be polluted. In this way, we can identify the one of the precaution. And the second thing is, by the using the filtrations, so that polluted water is not directly released into the water bodies. before leaving into the water bodies, we must apply some treatment by removing that solid waste or chemicals will reduce the water pollution. And finally, various techniques must be used, especially we called as green chemistry. So, by use of green chemistry, we can reduce the release of pollutant levels in atmospheric air. Okay. So, here some methods will be prescribed. Let us discuss one by one. In that dry cleaning of clothes, generally that clothes are dry cleaned by using the chemical tetrachloroethane. We know the formula of tetrachloroethane. So there is double bond between the two carbons and each carbon carries two chlorines. Actually, that use of tetrachloroethane will cause the soil pollution. That's why that use of tetrachloroethane is limited. In that place, that liquid carbon dioxide is used. That liquid carbon dioxide is used as a solvent for cleaning the cloths. This will be the somewhat better than the previous one. Later on, it can be also replaced by the other chemicals like hydrogen peroxide. So, in this way, we can reduce the soil pollution and water pollution. And second thing is bleaching of paper. So, during the manufacturing of paper, various chemical treatments are applied, and finally that color of the paper will be decided by its bleaching action. That raw paper is treated with chlorine. So, by the use of chlorine, pollution levels are identified. Now, that can be replaced by the chemical hydrogen peroxide. This is the second example. And the third example, that selection of chemicals during the preparation of chemicals. So, selection of chemicals. We can select the chemicals which can produce only products without producing any byproduct. For this, we go to an example. Let us take ethene, CH2 double bond CH2 ethene. On oxidation, in presence of that copper plus 2 or palladium plus 2, the required product will be obtained 90%, that is ethanol. It is the only main product. It is the main product without producing any byproduct. So, in this way, we can prepare the chemicals, whatever may be the required, by avoiding the byproduct. So, all these under the category of green chemistry. So, in this way, we can reduce the pollution. So, this is all about content present in the environmental chemistry. So, overall simple things will be asked in previous years. So, by revising these points, we get easily answered the question. Okay. Now, we move to another chapter, that is S block elements. That is a S block element. So here the weightage of the chapter is also 1 or 2 questions. Mostly they are in the mixed format. That means those questions will be is a combined format of 2 groups. Actually we know that S block contains 2 groups. One is 1A group and another one is 2A group. So here that questions may be asked individually from 1A group or 2A group, or it may be a combination of these 2 groups in the format of correct set of statements or incorrect set of statements, or this may be also mixed with the P block. So previously already we are learned about the P block elements in first year chapter, that 13th group and 14th group elements. So various kind of questions will be produced from this inorganic chapter. So mostly the questions will be in the format of statements, statement wise questions or correct and incorrect statements. In this way different versions of the questions will be asked from this chapter. So in inorganic part, reading of textbook is very, very important, because questions are directly asked from these statements. So let us discuss the main things in this chapter. So here there is a general introduction that S block will be present on the left side of the periodic table, extreme left side. An s orbital can accommodate 2 electrons. That's why 2 groups are present. One group is nothing but 1A group, another group is nothing but 2A group. That 1A group is also known as alkali metals, and 2A group is nothing but alkaline earth metals. So why these are called alkali and alkaline earth metals? Because their oxides and hydroxide are alkaline nature. Alkaline means basic nature. And these metal oxides are present in the earth crust, especially that oxides of 2A group will be present in earth crust. That's why we call it as alkaline earth metals. Okay. So coming to the first group, that first group, the elements present: lithium, sodium, potassium, rubidium, cesium and francium. These group elements are said to be alkali metals. Actually, based on the configuration, hydrogen is also placed at the top place. But here we are discuss only about alkali metals. That's why we cannot mention. Hydrogen. So here also hydrogen is there. We left that hydrogen, and the remaining elements are said to be alkali metals. Okay. So in this, sodium and potassium are the more abundant. So in this group, that sodium and potassium are more abundant, whereas the remaining will be very less. Remaining means lithium, rubidium, cesium. They have much less abundance. Here, francium is a radioactive element whose half-life period is only 21 minutes. Only 21 minutes. Actually, the radioactive elements life will be measured by using half-life period. So it is the time taken for the completion of half of the quantity is indicated by T half. So here that francium is highly radioactive. It's the longest lived isotope, francium 223, that has only 21 minutes. This is all about alkali metals. Coming to the general description of 2A group elements. Those 2A group elements are said to be alkaline earth metals. Alkaline earth metals. So here that starting element is beryllium, magnesium, calcium, strontium, barium and radium. So here beryllium is rarely available and radium is the rarest of all comprising that elements. So very little bit amount of radium is available and radium is also a radioactive element. So here the general electronic configuration of S block, because these two group elements are placed in S block, that general electronic configuration is NS122. NS122 is the general electronic configuration. So while going to the individual configuration, so alkali metals has a configuration of NS1, whereas alkaline earth metal has a configuration of NS2. So this is the general electronic configuration of 1A and 2A group elements. Now coming to the elements, group 1, that is alkali metals. So that elements present in this group are lithium to francium. When you observe the outermost configuration, everyone has configuration of NS1. NS1 is the outermost configuration. Okay. Let us go to the general physical properties. In that first one, atomic radius. As the down the group, number of shells increases. For example, here 2s level, 3s level, 4s level, 5s level, 6s level, 7s level. Gradually that outermost shell radius increases, that's why atomic radius increases. From lithium to francium, there is a gradual increase in the size. Actually, our discussion is always going on up to non-transition elements, that means non-radioactive elements, that means up to cesium. So here the atomic radius is gradually increases. Generally we can represent it in a graphical way. From lithium to up to cesium, there is a gradual increase in atomic radius. So atomic number on x-axis Z, atomic radius on y-axis. So there is a gradual regular increase in the atomic radius. So it is common in all groups. Coming to the second point, that is ionization enthalpy. So we have a knowledge, both ionization enthalpy and atomic radius are inversely proportional. With increase in atomic radius, that ionization enthalpy, that means removal of electron, will be easier. So that graph will completely reverse to that of the previous one. So here highest ionization enthalpy observed in lithium and lowest ionization enthalpy observed in cesium. So from lithium to cesium, there is a gradual decrease in the ionization enthalpy. So ionization enthalpy and atomic radius both are inversely proportional to each other. And coming to the third one, hydration enthalpy, very important fact. So hydration enthalpy is nothing but that energy will be liberated whenever that ion is surrounded by the water molecules. So here that hydration enthalpy of alkali metals gradually decreases from lithium to cesium. When you compare the sizes of these hydrated molecules or species, lithium is the largest species. That hydrated lithium is the larger size, whereas that hydrated cesium is the smaller size. So gradually there is a decrease in the hydration enthalpy. because that smaller lithium ion is surrounded by the more number of water molecules. Whenever that solvation will be high, then the liberated energy also high, so that lithium ion has more hydration energy. That hydrated molecule size will be also larger. In case of cesium, normal cesium ion is the larger one. Whenever that larger cation is surrounded by the less number of water molecules, that hydrated molecules size will be lesser. That's why in hydrated state, lithium plus is the larger one and cesium plus is the smaller one. For this, there an example is also given that lithium chloride. Actually, lithium chloride is covalent nature, because as per Fazan's rules, as the size of the cation is smaller, that compound must be covalent. So here that covalent compound lithium chloride is hydrated with two water molecules. So hydration is the common phenomena that will be takes place in alkali metals as well as alkaline earth metals also. Okay. Coming to the other physical properties, in that flame test, actually alkali metals will produce different colors whenever they are exposed to flame. So here the first element lithium will be appeared as a crimson red. Here some wavelengths also mentioned. It will be released a wavelength of 670.8 nanometers. Coming to the second element, sodium will exhibit yellow color, potassium will exhibit violet color, rubidium will exhibit red violet, and cesium will exhibit blue violet. So actually that color of the species is due to the presence of unpaired electrons. So whenever that flame test will be observed for these alkali metals, different alkali metals will give different colors. So mostly questions will be also asked from colors also. So here different techniques are used for flame photometry or atomic absorption spectrometry for the observing the colors. So one of the important factor of these alkali metals is color. After that, a general table will be discussed. We discuss already atomic number. We know the atomic number of all the elements, and atomic mass gradually increases from lithium to cesium, and outermost configuration is NS1 is the outermost configuration. And already we are discussed about ionization enthalpy. Gradually ionization enthalpy decreases from lithium to up to the non-radioactive element cesium, and also francium is also is given, that is nearly 375. And hydration enthalpy is always negative. Negative means that release of energy. That negative sign indicates release of energy. So here more amount of energy is released in case of lithium. Gradually that liberated energy will be occupied the lesser value. And metallic radius or ionic radius already we are discussed. From top to bottom, gradually either metallic radius or ionic radius. Mostly they form unications. Unications means they contain one unit positive charge. Gradually that positive charge ion, or we compare the normal elements, that atomic radius gradually decreases. And one more important thing is melting point. Here that melting point and boiling point of these alkali metals will be in the decreasing trend. For example, melting point, highest melting point shown by the lithium. From lithium onwards, gradually melting point decreases. In case of boiling point also, that gradual decrease in trend of these group elements. Coming to the density, so here there is a exceptional case of density. Let us observe. Here that the density of lithium is 0.53. The second place element, that is sodium, has 0.97, whereas potassium has 0.86, and rest of the other elements gradually increases. Here you can observe that the density of potassium is lesser than the sodium. Why? That is the main reason. The density of these group elements gradually increases except potassium, because density is measured by using the formula mass by volume. So from lithium to up to cesium, atomic mass increases, atomic volume also increases. But in case of potassium, there is abnormal increase in volume. In case of potassium, abnormal increase in volume. Because of abnormal increase in volume, because vacant orbitals are identified in potassium, that's why there is an increase in abnormal increase in volume. Even though increase in molecular mass is identified, with increase in molecular mass, that increase in volume is dominant. That's why density will be slightly lesser than the sodium. So here we must remember that the density of potassium is less than the sodium, whereas general trend is down the group density increases. Coming to the standard electrode potentials, here the SRP values of these group elements gradually moves from more negative to less negative with some exception. That exception is identified, in which case one thing is 2.74 sodium. So highest reducing power SRP can be exhibited by the lithium. Lithium after rubidium, and the least one is the sodium. So lowest density will be exhibited by the lithium in previous case, and the exceptional case of density is the potassium. At the same time, that SRP values, lowest value can be shown by the sodium. So all these are the important points that must be required for a different way of questions, mostly correct order or incorrect order. Okay. So what about the chemical properties? Okay. So these chemical properties we must be discussed in a later class. Okay.
JD and problem in the marks.